Good morning. Today in this class we will discuss about some basic terminologies related to statistics. We will look at some of the key definitions which get quite frequently used in statistics. To begin with, we will try and understand what population is. Population is any data point that I'm planning to study. All the data points that I'm planning to study is referred to as a population. Right? It is nothing but the universe, which means that it is the mother of all data sets that I'm planning to study. It will have all the data points in it. That's what is referred to as population. And it is denoted by the capital letter N. And anything that I measure about the population is referred to as parameter. Right? Or you can also say that the characteristics of the population is parameter. Right? And whenever you see the term parameter, you can say that you're talking about population, right? That's also one way of identifying if someone is talking about population or something else, right? So there are 3 points that you need to be aware. One is that population is the whole data set that I'm planning to study. It is the universe. It is the mother of all the data, which means that it has got everything in it, right? And it is denoted by the capital letter N. That's point number 2. And the point number 3 that you need to be aware of and remember is the term parameter. The term parameter is linked with population, and it talks about anything that I measure about the population, right? Now, let's look at sample, right? Sample is nothing but a subset of the population. Okay, it is just a part or a small section of the universe that I'm talking about. So it is a subset of the population, right? And it is denoted by the capital letter, not the capital letter, sorry, the small letter N. And anything that I measure about the sample will be referred to as statistic. Okay, so here again, like there are 3 points, right, which you should be aware of. Sample is a subset and it is denoted by small letter N. And anything that I measure about the sample is referred to as statistic, right? So this is about the sample. Now, let's look at an example for sample and a population. Okay, so let's say that I want to study about diabetes in India, right? So when I want to study about diabetes in India, then and the population, right, would be all the people who have diabetes in India will be considered to be as your population, right? Diabetes in India, right? So all the people will be considered to be as your population, and a sample would be like picking up 100 diabetic patients from all the states in India, right? So this is going to be considered to be a sample, right? So this is an example of a population and for a sample, right? The population has got its own drawback, right? Population, like I said, it is going to be the whole universe, right, that I'm planning to study. Is it really possible for anyone to study all the diabetic patients in India? It's really not possible, because first of all, you will end up spending more money to survey it and then track it and record it. You have to spend more money, and then you have to spend more resource, right? And also the time is going to be, it is going to be taking more amount of time to complete the whole task of surveying all the diabetic patients in India. And also this particular data set that you're talking about is going to be grow, right? Sometimes, right, by the time you complete, there could be few more diabetic patients who could have come into this particular bucket of tracking, right? So it's really impossible for us to measure the whole of the population. So the solution that you have is to measure or look at the sample, right? So what you do is that you go to all the states in India and pick some random people, right? Random people of 100, or it could be based on the population, right? So sample, when you talk about sample, there are few characteristics, or there are few criteria that has to be met, right? One is that it should be random, which means that there should not be any bias in it, and then it should be representative, right? Let me push it up a bit. Right, it should be random in nature. The sample should be random in nature, and then it should be representative, and then you should have sufficient data points. right? These are all some of the basic characteristics when you try to form a sample, right? And these characteristics should be met, right, in order to form an ideal sample. What do you mean by random? Random means like each and every element in the sample should have equal opportunity to get selected, which means that I randomly pick this or this or this or this. All these data points have equal opportunity to get picked up, right? That's what you refer to as random, right? And it should be unbiased, right? There is no bias to it, which means that I'm not giving any importance to this data point. I'm giving equal importance to all the data points that I have here, right? So it's a must that the sample should be random in nature, and then it should be representative. What does it mean? It means that there should be representation of diabetic patients from all states in India, right? That's what it means. It should be representative, means it should cover all the states in India, right? And also, like, you should look at sufficient data points. It's not that I take one sample from each and every state and say that I have found my sample, right? It's not going to help you, right? Probably you should have about 100 diabetic patient, which you take from each and every state, right? But again, like, this number selection is also debatable, right? Which means that I cannot go and fix, or I cannot go and say that I'm going to take only 100 people from all the states, because it is not a true representation of the population. The reason is, if you look at the population of the states in India, right, I guess that UP has got the highest population, followed by Maharashtra and then Bihar, right? So basically, when you so this is the highest, this is the second highest, and this is the third highest, right? Which means that when you pick up the sample should be in the same proportion, which means that in your sample you should have more candidates coming from UP and more candidates, and the second highest candidate should be from Maharashtra, the third highest candidate should be from Bihar, right? So on and so forth, right? That's how your sample should be formed, which means that it should mimic what you have in the population. The ratio of distribution of data in the population should be similar in the sample also, right? That's the ideal rule, right? Which you have to ensure that is being met, right? So let's summarize what we have seen so far, right? So we discussed about what a population is. Then we discussed about how you represent the population and what a parameter is, and then we also looked into sample. Then we started to look at a example for population and for a sample, and then why population cannot be used, right? And why a sample gets used, and how a sample has to be used, right? Now I talked about some of the drawbacks related to population, which is going to be cost, resource, and time, right? In the case of sample, right, what are the drawbacks that you have? Drawbacks could be right, it could be biased in some way or other, right? The next thing is that, like, it is not going to be 100% representative of the population, right? These are the two major drawbacks that I can list out in terms of sample. The reason is, right, most of the cases, like most of the time when you start picking up the data, right, some form of bias tend to exist, right, without our knowledge, right, so that has to be properly addressed. The next thing is that it is not going to be 100% of the population, which means that you're bound to have some kind of an error, which is referred to as sampling error. Okay, so what does it mean? It means that let's say that the mean of the population is 50, right? Which means that I have considered all my 1 million records, and then I got this particular mean number, which is going to be 50, which is going to be 50, right? Now when I take a subset, say, like, I'm taking about 1000 data points from here, and then when I start to look at the mean and determine the mean, it will not be exactly same as 50, right? Probably, like, it will be close to 50, or it may be like less than or equal to 50, right? But it may not be equivalent to 50, right? And let's say that this is my sample 1, right? And I take another sample, right, of same number of records, and I call it a sample 2, right? This time I might get a sample mean of 48, the next time I might get a sample mean of 52, but it is not going to match with my population. This difference that you see here is referred to as sampling error, and this sampling error is not going to go away no matter what you do, right? When it comes to unless otherwise you consider the whole of the population and study the whole population by some way, right? You will always have a sampling error, right? So this is the drawback in terms of using sample. right? One is that the bias, right? And the next thing is that it is not 100% representation of the population. And when it comes to the population, the drawback would be the cost, resource, and time that we discussed over here, which means that like I will end up spending more amount of money to measure all the people in the population, and then the resource, I need more amount of people to go and do a survey or collect information, and then the time, it is going to take huge amount of time to cover all of my population, and this is basically impossible for me to like measure or infer few things about the population. All right, so let's come here and see like what has been written or what I have noted down here. So first thing we discussed about population, right? That is done. And then we discussed about what a sample is. Then we looked at what example for sample in the population. Right here I have listed one more example, right? Which will which will discuss about population and for the sample, right? Let's say that like my aim is to find the average height of Indians above the age of 30 years, right? So in that case, my population is going to be all the people who live in our country, right? That's going to be my study interest, right? So that's a huge number, right? So what I do is that I take random observation, right? And I see to it that it is unbiased and then it is representative, right? That's how I form a sample, right? So this is another example which I have given for sample and for population. And then we have a term called sampling error. I think we covered that also, right? Since we take a sample and study about the population, we always tend to have sampling error, right? And yeah, so this is something which is interesting, right? There are different ways. I told you that we need to form a sample, right? What are the methods by which can you form a sample is important, right? A simple random sample is one of the first method, right? What you do here is that it's a random pick of the data points from the population, right? Which means that I have, let's say that I got 4 points, right? Let's say that let's keep it as 8, 9, 10, right? I can pick this, and form my sample right here. These data points have equal opportunity to get picked up. It is going to be unbiased, right? So this is one of the best ways of forming a sample, right? And the next method is going to be convenience method, right? Over here what we do is that it is based on our convenience. Let's say that if I'm studying in a college and if I stay in a hostel, right, what I will do is that I will not go and survey all the people in the college. I will look at people who are in the hostel, right, who stay with me, and take the opinion, and then I project it for the whole of the college, right? So it is based on my convenience, right? It is based on what I feel is is likely to be done, right? It is quick and it is easy, but it is going to be biased because I am biased and I am moving towards people who stay in the hostel with me, right? So this is based on my convenience that I'm forming the sample, right? So this is one more method by which I can form a sample. And the next thing is going to be systematic sampling. Over here what we do is it's going to be more systematic in picking up in forming the sample data set, right? Let's say that I got about 100 data points. That's my sample. That's my population, sorry. My population is going to be 100 data points, right? And I need to form a sample wherein I have about say 20 points. This is just an example which I'm giving, okay? 20 points has to be formed. So what I will do is that the first data point that I pick up will be random. Okay, the first data point is going to be random, and the rest is going to be like equal intervals of 5, right? So what will happen is that there is a systematic way by which I select the elements from the population, right? So basically this is more organized way by which I can form a sample, but again there is a possibility that I will end up having a bias. The reason is that if there happens to be some kind of a pattern in my data, then since I'm doing a systematic way of selecting the elements, there is no randomness in it, right? So that will happen that will screw my sample, right? So let me explain again. I have 100 data points. That is going to be my population, and my requirement is to form a sample which is going to be 20 data points. The first data point I select will be random, and after that, whatever points that I select, right, it will be in the interval of 5. Thereby I end up getting a sample of 20, right? So this is a systematic way by which I can form my sample, right? And the fourth method that we have here is clustering, right? Which means this is most commonly used, I would say, like more prevalent, right? When you start forming a sample, right? Here what we do is that we will form different clusters: C1, C2, C3, C4, C5, C6. After I form the clusters, I randomly pick any of the clusters, right? Probably I would end up picking up cluster C2 and cluster C6. So which means that all the elements, this cluster could have about, say, like 200 points. This might have about, say, like 400 points, right? What will happen is that I will be considering all the points, all the data points which come under that cluster for my sampling. The rest of the clusters will not be considered, right? And then we have something called stratified sampling, right? So this is slightly trickier. The reason is we have a few additional steps which gets performed over here. Let's consider that this is my population, okay, and I have different objects in it, like I got stars, I got circle, I got square, I got star, I got circle, right? So first thing that you do is that you will form different groups based on the characteristics, right? The characteristic is going to be the shape, right? Say for example, I could group all the stars together, I could group all the boxes together, and then I will group all the circles together. Let's say that the star is contributing to 50% of the data, and this is contributing to 30% of the data, and this is contributing to, say, like 20% of the data. So what I will do is that after I form these different buckets or stratas or classes or groups, I would pick up random 50% of data from here, and I will pick up random 30% of data from this group, and pick up random 20% of data from here, right? And then I will form a sample. Okay, so this is what a stratified sampling is all about, right? First thing is that you start grouping your data based on some characteristic, right? This is something that the person who's working on the data will come up, right? Let's say that I'm working on the data, so then I say that I form the group based on the shape. So I form 3 different groups here. Then I look at what proportion they occupy in the population, right? And then I say that, okay, fine, star is having about 50% of the data, so my population should have random picks of 50% of data points coming from the group which is having star, right? Likewise I do it for other groups, and then I form my sample, right? So this is another method by which we can form a sample, right? So that's what I have discussed here. That's what I have written over here. So we discussed about simple random sample, where you pick up things random. This is one of the best ways. Convenient sample, it's based on my convenience that I do. Systematic, there is a systematic way, which means that I pick up things based on regular intervals. And cluster sampling, here I form different clusters and randomly select the clusters. In stratified sampling, I form stratas or groups based on some characteristics, and then I form my sample based on what proportion of data I see in the population, right? So we covered all these things which I have mentioned over here. Now let's look at the next important terms which we will come across. It's going to be variation and sampling error, right? Variations, what do you mean by variation? Variation is nothing but the change that you see in the data, right? Which means that the difference that you see in the data, right? Let's say that you are trying to measure something. Let's say that you are looking at the data wherein you are looking at the height of students with age 8 years, right? And if you look at the data, like not everyone would have the same height, right? You will find differences, right? Or let's say that you are measuring the height of Indians, right? About the age of 30 years. Like someone would have 5 feet, someone would be 5 feet and a few centimeters or inches, right? So what I'm saying is that, like, the height that we are trying to measure is not going to be constant, right? You will find changes, right? You will find variations, right? That's natural, right? You can't expect all the people to have the same height in India, right? And or you can't expect, this particular variation applies for everything, right? It's not only for for the project that I'm doing it. The variations, you find it everywhere. Even if you consider a product which has been manufactured by a machine, you will find variations, at least to a decimal of about, say, like, 0.0001, right? You will find some kind of variation, right? Let's say that, like, you have a medicine, right? And then if it is going to be like 50 mg capsule, right? And all the capsules should have the same weight, right? But if you measure it to the precision, you will find some kind of a difference, like, 0.00001. There will be some difference, right? So variations are natural, right? Variations are natural to occur, right? That's what you refer to as natural variations, right? And then explainable variation is also referred as a confounding, right? So what does it mean, right? Let's say that, like, you're trying to look at the study hours for 8-year kid, right? So this study hour is going to be is dependent on a lot of other factors, right? It could be about the gender, right? Could be related to the parents, it could be related to the school, it could be related to the teacher, right, who's taking the class, right? There are a lot of factors which will, right, influence the study hours that an 8-year kid puts in, right? So all these, the study hour could be explained, right, with the help of these variables, right, that we are talking about. This is what you call it as explainable variation, which means that can you explain the variation which is happening with the help of some other factor, right? That's what you're talking about, right? So we talked about variations. Variations are natural, right? In data, you will not have constant data which is coming, right? You will see minute variations in the data points that you collect. Natural variations, right, which is bound to occur in anything and everything, right? And then explainable variation, which means that can you explain it, right, why the variation is occurring, right? That is what you call it as explainable variation, right? Sampling error, right? I think we discussed about it earlier. Like, let me give a few more pointers. The sampling error, right, will definitely occur when the term sample comes into picture. The sampling error is definitely bound to occur. What does it mean? It means that, let's say that, I take a sample of 100 students, and I'm studying about their hours spent for studying, right? It could be average, could be about 8 hours, right? And let's say that my friend is taking a sample and then he's studying, and then it could be about like 6 hours, right? There is no constant. These things are changing because over here the sample, right, the elements that I have in the sample is different, right? That could be someone who could be studying very low number of hours. You could have someone who's studying for high number of hours. Because of that, you're bound to find some kind of variation which is happening over here, right? So this is so you would always tend to have some kind of variation when you compare it with the population, right? That's what I'm trying to say, right? This, even among the samples, right, you will find variations, because, like, the base element which goes into making the sample is different, right? And since we're not studying the whole population, right, you're always bound to have variations, and these variations are referred to as sampling error, right? So we discussed about sampling error. Some of the pointers is that, like, let's say that, one thing that you should remember is when my sample size increases, which means that when my sample size increases, which means that I'm moving towards the population size, which means that, let's say that, my sample size is 4 and my population size is 100, right? At this point of a time, the variation that I see between the sampling error that I see here will be very high. But on the other hand, if my sample size is increased, I have to say, like, I'm taking 99 data points of my total of 100 data points that I have, right, the error that you see will be very low. So what I'm trying to say is that when the sample size increases, the sampling error decreases. When the sample size is very small, right, then you're bound to have a huge sampling error, right? So these are the pointers that you have to keep in mind. So basically, we would try to minimize the sampling error, which means that we will try to increase the number of data points that you have in the sample, right? So we will discuss on how we can fix it, and what is the optimum, what is the right level of data points that I have to have in a sample in the next class, right? So so this is what I want to cover in this class, right? I hope that you had a very good session, and thanks for spending time with me, and I hope to see you guys again in the next class. Thank you guys.